started with some lexical convention of the Verilog program, right? That we started with number representation, positive number representation, negative number representation. We talked about string, how to print a string, what is a string, then what is the use of underscore and question mark in the Verilog programming. Then we talked about data types, right? So in the data types, we started discussing about the data types is, the first data type we talked about is nothing but what? Net data type, correct? Net data type. What is a net data type? What is the use of this net data type? Net data type used to connecting between the two hardwares. So this net data type is the what driven data type it is. So why it is a continuous driven data type? It cannot hold the value. Storage is not there in the net data type, right? So where it is continuously driven, so where input changes, it is continuously computing the output. So that the net data type is we call it a continuous driven data type, where reg data type is nothing but a discrete driven data type. Correct. So what is the keyword we are used to declaring this net data type? So will be the keyword is used to declaring this net data type is nothing but while data type. What is the default value of this? Default value of the net data type is Z. What is Z is? High impedance. Correct. High impedance. Then what is this is nothing but if I am writing example, like example Y bus A. What is this is? Y bus A. So this is a default with what is the size of this bus is? Scalar means a 1 bit data type it is. Now if I am writing a Y, so let us take summing down to 0, bus A, what is this is? It is a vector. What is the vector width is? Vector width is A. So how to find out the vector size? Absolute values of MSB plus LSB plus 1. Correct. Did you understand this? Now, what is the second data type we talked about is? Second data type is nothing but reg data type. Reg data type. So what is this reg data type is? So reg data type is used to store the data. Storing of the data. Okay. It is a what driven it is? It is a continuous driven. It is a discrete driven. It is a capable of storing. Storage capability is there in the reg data type. So that we call this a discrete driven data type. Okay. So what is the keyword used to declaring the reg data type is? We call it as a reg data. Where reg data type is a unsigned data type it is. What is mean by unsigned data type? What is mean by signed and unsigned numbers? Signed numbers are from minus to the plus. Unsigned numbers is from 0 to the plus. So this reg data type used to store the what data? Unsigned data. Unsigned data. So this is a keyword used to representing the reg data type. Okay. So what is the default value of this reg data type? Default value of this reg data type is unknown, X value. So how you can declare in the reg data type? Using a keyword reg. So if I write reg A, this means what? Yeah. Scalar. Correct. Reg 7 down to 0 is nothing but what? Vector. Is nothing but a vector whose width is nothing but 7. So today we'll go with another data types is a integer data. Integer data type. So integer data type is different from your reg data type. Reg data type is what? Unsigned number representations. Where integer data type is signed number representation. You can store what? Means you can assign the negative value or the negative value to the positive value. So let us talk about the signed integer data type. So you can see the integer data type An integer is a general. What is the use of this integer data type? First we'll understand. So this integer data type is using for the general purpose register operation. So like addition, subtraction, incrementing the variable or decrementing the variable. So we'll be using the integer data type. The integer is a general purpose register data type used for manipulating the quantities. Manipulating the quantities like addition, subtraction, increment and decrement. So this integer are declared by the keyword called it as what? Integer. So what keyword used to declaring the integer data type is using keyword integer. So it is possible to use the reg as a general purpose variable, correct? So it is more convenient to declare the integer variable purpose of such as counting. Suppose in the case of I want to count the loop, incrementing the loop. So in such cases, I can declare instead of going with the reg data type, I can go with what? Integer data type. Where this is general purpose manipulating the quantities in the program. So by default, it is an integer will take how many bits? 32 bits. It is system dependent. It is a machine to machine. So default width for the integer is host machine word size, which is implemented specific, but at least integer will take how many bits? 32 bits. So register declared as a data type is register value. So this register declared as a data type is reg, which is stored what quantities? Unsigned quantities. These are unsigned quantities. Where integer store the values what? Signed quantities. Unsigned quantities is nothing but the values which it takes from 0 to the plus. Signed quantity is nothing but it will take the values from 0 to positive, means minus to the plus. If I'm writing like this, suppose, let us take an example, reg. So let us take integer. Integer A. What it indicates? A is a data type of what? Integer. It is an integer. What is the width of this is nothing but? I mean, what is the width means? What is the size of this is nothing but 32. So this A will take the values of what? Positive number and negative number. Yes, this is same as this one if I am going to reg data type of 31 down to 0. Okay. Is it same? Is it same or different? This is a register of what? What is the size is 32 bit. This is by default integer is also 32 bit. Is both are same? And what sense both are same? In what sense both are not same? Look at this point. Register declare as a data type reg store the values of what? Unsigned quantities. Whereas integer stores the values of what? Signed quantities. Now if I'm writing like this, integer A, now it is what? It stores the quantities of signed numbers. Now this is nothing but only unsigned numbers. It is same, but this size is same and this size is same, but this reg is used to store the what? Unsigned quantities. This integer is to store the signed quantities. Did you understand this difference between integer and the reg 31 down to A? Correct. So what is the use of this integer is, like suppose integer, what I am doing here, integer, counter is a variable. So I am using this initial block to making count to what? -1. So this is a general purpose variable used as a counter here. So here a -1 is stored in the counter. Correct? Since I have declared counter is a what? Integer data type. It takes minus to the plus. Now let us write a small program understanding of the integer. The program is write a program of addition of two numbers. Addition of very simple program. Write a program of addition of the two numbers. Addition of the two numbers. So how to write a program to this? Let us write a program to addition of two numbers. What I need to start from? Verilog module name. So in this case, module name, I don't have any port list. Now I'm not going to modeling the hardware. If I'm modeling the hardware will be having inputs and outputs and in-output ports. Did you understand? So here I'm just doing the addition of two numbers so that my module does not contain any port list. Did you understand this statement? So module TB is nothing but what? Module name means TB. I'm just writing TB is nothing but test base. Okay. Now to add the number, what I need to do? We need to do the port. Port declaration. If you are using the ports, port declaration is required. Now to add the two numbers, I need two variables. Correct. So what I need to do? I need to declare the two variables. So this is a declaration part, right? After module name followed by what? Port declaration or variable declaration. Correct. So here I am going to declare the integer. Let us take integer a comma b. So how many variable I am declaring? Two variables. What is the variable is? A and b. Now I want to do addition of two numbers. Addition of two numbers. How to do? I need to write it in the what? Assigning the value to the variable done through what? Initial block, right? It is like your void main in C program. So the statement goes where? Inside the void main. Correct? Void main. You are writing like this, right? Void main. Then what? Void main function followed by open bracket. Correct? Then we are closing this. Did you understand? So this is a syntax of what? C programming. Then how you can do in the Verilog? You should start with initial. Initial begin. Begin is nothing but open flower bracket. Then end is nothing but closing the flower bracket. Here we are using begin and end. So inside this, I am going to initializing the value of A and value of B. Then I am computing addition of two numbers. Did you understand? Now how to assign the value of A? Suppose if I am going to write like this, what is this is nothing. A is equal to 25 means A will take what value? What number? Decimal number. Correct? A will take the decimal number. If I am going to write like this, 32 tick H. It is a hexadecimal number. If I am writing 0 octal number. If I am writing B, binary number. We understand how to represent the number specification. So I want to add two numbers. First I am going to initialize A value. A is equal to 25. Then B is equal to, let us take 10. Correct? Then what I want to do? I want to print this. First I want to compute the addition operation. To do the addition operation, what I want to do? Well, how to do the addition operation? A plus B. A plus B operation I want to store in the variable, correct? Assigning to the variable, so that I need to declare one more variable. So integer A comma B comma C. Then what I need to do here? C is equal to A plus B in the line. Then I want to print the values of A, B and C. So what I can use? Dollar symbol display. It is same as in your printf in your C programming language. Dollar symbol display of, correct, what I want to display. Now I need to write the formatted string, then I need to pass the argument. So first I am going to print the what? Value of A, then escape characters, backward slash T is nothing but one tab space. So B is equal to percentage B, tab space, C is equal to percentage B. Then I need to pass the argument. This formatted string will be separated by comma. Then what argument I need to pass? What is the order of argument passing is? A comma, B comma, C. Then I should end with the line. Now I have entered initial begin here. This initial begin is ended here. Now what I need to enter one. Enter. Now this is going to print what output? What is the output of this program? So 25 plus 10 is nothing but 32. Now it will print the output as 32. Now since I am printing this in what? Binary. So let us print this in the decimal. So decimal 0D, 0D, 0D. Now this will be printing in decimal. A is equal to 25, B is equal to 10, C is equal to 30. So if I am not going to use here 0, what will happen? Since integer, I have declared C as an integer, default it will take how many bits? 32 bits. So if I am printing B, it will take all 32 bits to fill. Correct. If I am doing D, it is printing like this. So this completely will take 32-bit representation in binary. To remove this, what I have to do? You should add the 0. To remove these white spaces, add the 0. If I am doing 1D, 1 space will be removed. 2D, 2 spaces. You to understand. So now I am using the integer data type here. What general computation I have done in this case is nothing. Addition. Correct. I am doing the addition operation. A plus B. So A is declared as integer, B is declared as integer, C is declared as integer. I am doing the addition operation. Then I am printing this. This initial begin is like your void main in your C programming. Okay. In Verilog, concept called it as a module concept. Modules followed by the module name. Always you should have a practice to end the module. Did you understand how to use the integer? What is the difference between while data type, reg data type, and integer data type? So if I'm using like this here, reg 31 down to 0. Is I'm getting output or I'm not getting output? I'll be getting the output because all A, B, C are declared as what? Reg data type. Its size is what? 32. A will take the 32 bit. B will take the 32 bit. C is also takes the 32 bit. But the reg data type is nothing but it will take only the unsigned quantities. So that is a difference between integer and the reg. Did you understand? What is the purpose of the integer data type? Now let us go with the next data type is nothing but real data type. Real data type. So the real data type is like to print the floating number. So initializing the floating number, so we go with what? Real data type. So this real number constants and real register data types are declared with the keyword as called as a real keyword. Real keyword. So this is one of the reg data type only, register data type. Okay, these are all integer. Okay, real time. All these are, we call this a register data type. So these real data types are used to specifying the scientific notation number. What is scientific notation number is? So they can specify the decimal notation as example 3.14 or in scientific notation of how you can represent 3 exponential 6. So this will be denoted as 3 into, this is a 10 power 6, not 106, it is 10 power 6 this is. So real numbers cannot have a range declaration. So this real numbers does not have any range declaration. Integer will be 32. Reg will be what vector we are declaring. Based upon the vector, we are going to specify the range of the reg data type. But in real numbers cannot have range declaration. The default values of the real is nothing but value is 0. Y is Z, reg is X. The default value of the real data type is nothing but 0. So when the real value is assigned to the integer, suppose your real value means what? Floating number is assigning to the integer, the real number is round off to the nearest integer. Now let us take one example to this. Okay. So what we have done here? Real. What is this delta indicates? Variable. Correct. Real is a keyword. Delta is the variable. Now initial begin delta is equal to what we are doing. This is a scientific notation of the floating point number 4 exponential 10. So this is delta is assigned in the scientific notation. Look at the second example. What is this is? 2.13. This is assigned, this is a floating point number. Did you understand? This is a floating point number. So let us take one example to this. So I am going to declare this as a real delta, initial begin. So what is the delta value we are assigning is? Delta is equal to, what is the value of this is? 4 exponential of 10. So what is this 4 exponential of 10 means? 4 into exponential of 10 means how much it is? So 4 into 10 power 10 is. So let me write the same. So this is 4 exponential of 10. Now I am going to print this value. To print this value, I am using the dollar symbol display. This is delta. Delta is equal to percentage D. Okay. Then A comma B comma C. Sorry, this is nothing but delta. I need to pass the argument as delta. Now let us print the number. This is a 1. Since I am printing in what? Decimal. So what is 4 e exponential of 10 is? This is a 1. How do you understand this? Now let us take what is another delta value is 2.13. This is a 2.13. 2.13. So what is my delta value is? My delta value it is printing. Why it is printing only 2 here? So what is the format specifier I should use to print the floating point numbers? Then I am declaring this as a real data type, floating point. Yeah, correct. Now what is the value I am printing is 2.13. So this is used to print the what number? Floating point number. Did you understand? I want to print only the 2 digits after this floating point. So by default, how many digits it is printing? 6 digit, correct? So this is 3. Again, this is 3. So default, if I'm using percentage, default it will print how many digits? 6 digit. Now I want to print only 2 digits. What I want to do? 0.2. Now this will be printing what? 2.13. So this will be printing 2.1. If I am using 0.3, it is printing after the floating point, it is printing the 3 digits. Did you understand how you can see? It is printing the 3 digits. So what is the real data type is used for printing what? Printing the what? Assigning the value of floating. Scientific notation value you can assign to the what data type? Real data type. If I am declaring this as an integer, what will happen in that case? Only let us declare this as integer. Now what it is going to be? Only 2 is it is printing. 2 point, since I am using the 0.3 here, the floating point numbers is printed after the floating point. 2.00, correct? So let us make this into real data type. So the value which I am going to assign is, let us take this one, 4 exponential of 10. Now I am printing, if I am printing a decimal, it is printing 4 into exponential of 10 means 4 followed by 5 zeros, correct? And if I am printing this in decimal, floating point, how it is going to print in floating point? I am printing this in the floating point. So this is the result. The floating point is 4000.4 followed by this number of zeros, not 5 zeros, this number of zeros dot 0 0 by default after the floating point, by default how many digits it is printing? 6. You know how to make this into printing only 2 digits, printing only 3 digits, correct? So how I can do? I can do 0.3 means now it is printing what? After the floating point, it will printing the 3 digits. Did you understand this example? Are you clear? So this real data type, so this real number constant and the real register data types are declared within the keyword is called it as what? Real. So this can be specified in the what? Decimal notation. Example 3.14 or a scientific notation that is 3 into exponential 6. So which is equivalent to what? 3 into 10 power of 6. So this real number cannot have a range declaration and the default value is 0. Correct. So when you are assigning the real value is assigned to the integer. When you are assigning the real value to the integer, then the real number is rounded up to what? Nearest integer. Now let us take this example itself. Here real delta is declared here. So for delta we are assigning 4 into exponential 10. Then delta is equal to what? 2.13. The same variable we are assigning the two different values. Correct. So then we are in this begin. Now integer I am declaring integer I. Again initial begin. So what is I is equal to delta? Then what is the I value it will take? Whether I value will take 4 into exponential 10 or 2.13. So what value it is going to print here? What value it is going to print? Let us take an example. So this is a delta, correct? So again in delta we are assigning what is the value? 2.13. 2.13. So now if I run this code, what is the value of this delta now? This is the first one or second one? Next updated value of delta will come here, correct? What is next updated delta value is nothing but 2.13. The output of this program is nothing but now it is 2.130. Now here I am assigning my real value to the integer. So for this, let us declare integer I. Integer I. So let me take one more initial begin. So I said that Verilog is a concurrent execution. What is meant by concurrent execution? And parallel execution. If you write 10 initial blocks, all initial blocks are start executing at what? At the zero simulation time. Parallelly it is start executing. The ending of this initial blocks will be depending upon how many statements you are writing inside the initial block. Did you understand? So now let me write one more initial block here. Now I am going to assign what I am going to assign here? Real value I am going to assigning. So now I is equal to delta. So what I am doing in this example is, what is the delta value is now? 2.13. That will be assigning to what? Integer. Now I am going to print the I value. So what is I value I am going to get in this case? Let us print the I value. I. Okay. This is also I. Now I am passing the argument as I to print the I value. Now what is the I value? Now let us in this initial begin. Okay. Okay, for your understanding, I am giving the indentation. What is mean by indentation? White tab spaces, right? Is it Verilog will follow the indentation? Is it Verilog is following the indentation? What is mean by indentation and is it Verilog is following the indentation? Indentation is generally using for code readability. Code readability means if I am writing all this like this, suppose this is the one I am writing, and like this if I write, you are not properly understanding that what is the statements. I mean, not easily understanding what is the statements of first initial block and the second initial block. Correct. To better understanding of this, what I am writing inside here. Okay. So what we are doing basically we are giving the white spaces. So white tab spaces, this we call it as an indentation. This we call it an indentation. Like Python program is following the indentation. Like other C language is following the indentation. C will not follow the indentation. But Verilog also not follow the indentation. But the code readability, we are giving the indentation here. I am giving the indentation. Correct? If I am not going to give the space also, this program will work fine. Correct? If I am writing like this also, this code will work fine. I am getting the result. Correct? If I am giving like this also indentation, I'll give the indentation like this, white spaces. Now you understanding that this is a one initial block, and these are three statements in my initial block. Easily you can understand. Correct? Now if I am giving here also white tab spaces here, now what you can understand? This is another initial block. These are the two statements of this initial block, so that you can easily understand the code. Easy understanding of the code or a program will follow the indentation. You should keep in mind that Verilog will not follow the indentation, but we used to give. Why we used to give the indentation? Better readability of the code. You don't understand? Now I am assigning my delta value to the I. Now I is declared as what? Integers. If I am assigning my real value to the integer, so what is the I value now? What is the I value now? It is I value will be rounding up to what? Nearest integer. What is 2.13? What is the nearest value of 2.13 is? 2. You to understand now, you can say I am printing the value of I here in this second display statement, and this is my first display statement. In first display statement, I am printing the delta value. This is the real value, floating point, 2.130. In second printing function, 2. So what I am doing in this program is, I am assigning my real value to the what? Integer. So that is what integer will round up. You can see when the real value is assigned to an integer, when the real value is assigned to the integer, the real number is round up to what? Nearest integer. Nearest integer. Now let us take one more example. What it is rounding up now? Now let me make this as 2.55. It is rounding up to 2 or rounding up to 3. Now this should be rounding up to 3. You can see it. Now am I assigning my real value to the one? Integer is rounding up to 3. So what about this one? It is assigning to the 2 or it is assigning to the 3. Rounding up to the 2 or rounding up to the 3. It is rounding up to the 2. 2.5, sorry. 2.5 will be assigning to the 3. If I am writing 2.49, now this will be rounding up to the 2. Now this will be rounding up to the 2. How do you understand? So when you are trying to assigning real value to the integer, so integer will always round up into what? The nearest value of the real number. Did you understand how to use the real number? Are you clear about integer and the real? Now let us go to the next data type. The next data type is nothing but time data. So Verilog will support one more data type because the hardware will be having a timing. So Verilog is supporting the time data type. The time data type in Verilog simulation is done with respect to the simulation time. Correct? Whatever the program you are running, that is done through what? Timing, simulation time. So a special time register data type is used in Verilog to store the simulation time. So this time variable is declared with the keyword is called as what? Time. The time variable is declared with the keyword is called, keyword we can use as a time. Time is a keyword. So the width for the time register data type is implemented specific, but it is at least how many bits? 64 bits. So the width for the time register data type is implemented specific, but it is implemented at least how many bits? 64 bits. The system function, what is this dollar symbol indicates? Whenever you see the dollar symbol display, dollar symbol monitor, dollar symbol random, what are all these are nothing but this is a system task function. So this system, this is one of the system task function. So this dollar symbol time is invoked. If you are using dollar symbol time, it is going to invoke to get the current simulation time. Current simulation time. Let us understand this example. So what is the use of this time? Data type. Did you understand? So what is the keyword we use to declare the time data type is? Dollar symbol, time, correct. So let us use the time data type. So what is the default size of this time data type is? 64. Correct, 64. Now let me print. I'm assigning. So what is the variable I declare to the time data type is? Yes. Now I'm using s is equal to dollar symbol time. What this will do? What is this dollar symbol time will do? This dollar symbol time will get it is going to invoke the current simulation. At what simulation time it is running. So that it is going to invoking using dollar symbol time. So I'm invoking that is assigning to what data type? Time data type. The time data type S is declared with the time data type S. Now I'm going to print the value of S. So S is equal to what format specifier I can use for the time data type is dollar means a percentage, not dollar. Percentage time will get the current execution time. Okay. This percentage is used to print the what? Time data type. Time data type. Now what argument I need to pass to this? Yes. Right. Yes. Now do you need this initial being blah? No. Let us remove this. Now what output I am going to get in this case is simulation. The current simulation time. At what time we are start simulating. So at what time this is start executing? This is start executing at the simulation time t is equal to 0. Now let us run this. Now I am getting the s value is equal to what? 0. By default it is how many bits it will take real time? 64. So to remove these spaces, what I have to do? 0t. Now this is executing at what time? At 0 simulation. Did you understand? Now let us take one more example. I am going to declare integer a comma b comma c. Okay. So I will be performing addition operation. So you know that what this will do, right? A comma b is equal to dollar symbol random. What this will do? What is dollar symbol random? It's going to generating the random value. How many size of the random value? How many bit size? 32. Now what is this I am using? Flower bracket a comma b. This flower bracket a comma b is nothing but concatenation now. I am concatenating the a and b. So this is an integer now. This is an integer. Now this dollar symbol random value will be assigning to a and b. Now what is the a value it is assigning? 32 bit, whatever the random value it is generating. Since a and b will be declaring as what? Integer, right? Now this b will takes how many bits? Is it 1 bit? You can see this is what? Integer data type. Correct? Integer data type. Now a will take how many bits? 32. B will take 32 because I am declaring this as what? Integer data type. Are you understanding? Now I am going to perform the operation c is equal to a plus b. Let us take a plus b and b. Now what operation I am doing is one arithmetic operation means addition operation I am doing. Are you understanding? Now I am going to use like this. Now this has to execute at hash 5. So hash 5 is nothing but what we call this nothing but a sim time. Time delay, or we call this is nothing but a sim time. Hash 5 is nothing but it is simulation. So the general meaning of this is hash5 is nothing but a simulation. You can understand. Now I am assigning S value. S is equal to what? Dollar symbol time. What is this dollar symbol time will do? It is going to invoke the current execution time. Correct. Now I am going to print the S value at what time it is executing. Also I am going to print what? A value. Let us print A value in decimal 0D. Okay. Then B value. B is equal to percentage 0D. Then cap space. C is equal to what? Percentage 0D. C also printing in the decimal. Now what are the argument I need to pass? A comma S comma A comma S is nothing but what? It is a time data. For S what I am assigning? What I am assigning to the S is it is going to execute the current simulation time. So that I am executing using what? Dollar symbol. Correct. Is A comma B comma C. A comma B comma C. Now what is the output I am going to get for this program? What is this S is going to print? Current simulation time. What simulation time I am asking to execute this? 5. Correct. And then what is the value of A? A and B I am initializing using dollar symbol random. So A will take 32 bit, B will take 32 bit because these are declared with the integer. Now C is nothing but resultant of A plus B means addition operation. Now you can see, so at what time it is executed? 5 times. Correct. And what is the A value it is taking? 0. So why it is taking 0 here? And random value will generate the 32 bit. So I am using concatenation operator. All this 32 bit will be assigning to the B. Is it true? Correct. Since dollar symbol random will be generating the 32 bits. Correct. I am doing the concatenation operation here. These 32 bits will be assigning to the B first. Correct. And by default, this A will take what? Zeros. Did you understand what is the meaning of this? What I mean to say, this is generating 32 bits like this. Random value. Like 32 bits, this dollar symbol random will generating the 32 bits. I'm using concatenation operator, A comma B. These 32 bits are assigning to what? First B. Correct? By default, A will take what? 0. In this program I'm talking about. Now what I'm going to do, let me assign individually. Then what will happen here? So if I'm going to assign like this, dollar symbol random, A is equal to dollar symbol random, and then I'm going to assigning B is equal to dollar symbol random. Now in this case, what will happen? Now A is taking 32 bit, B is also taking 32 bit. Correct? In earlier case, I was doing the concatenation. Only 32 bits of random values assigning only to the B, then default A is taking what? 0. Did you understand? Now what will happen if I run this? What is the output of this program? It is randomly generating A value, randomly generating B value, then it is printing the value of C. Now you can see this is my A value, correct? This is my B value, and this is nothing but C value. Since this dollar symbol random is a signed or unsigned, it will generating the random value of the signed or unsigned. Huh? Is it unsigned? You can see what is the B value I am getting is minus 1064. Signed dollar symbol random will generate the signed random values. To generate the unsigned random values, you can use the system task function is U dollar symbol U random. What is the dollar symbol U random is? U indicates what here? Unsigned numbers. Did you understand? Now this U random is unsigned numbers. Random is it is generating the signed numbers. Did you understand? Now A will take unsigned numbers and B will also take the unsigned numbers. What is the system task function I can use? Dollar symbol U random. Now A will take the sign number, B will take the sign number. This is the result. It is taking A value is minus sign here and using dollar symbol U underscore random. Should be unsigned numbers, right? I'm declaring integer AB, initial begin. So A is equal to U underscore random. Okay, it has to do one thing. Underscore range of 10, 20. So let me clarify this. This is a range of again 10, 20. I will clarify you. Okay, why this U random is also generating negative values, means signed number. Let me clarify this. Okay. So let us use this system task function. U random underscore range 10, 20. So what basically this will do is nothing but, what is basically this will do means it is going to generating the random values. Random values between what? What range? 10 to 20. 10 to 20. So this is the minimum range right here. This is the maximum range. It is going to generate the, in between this 10 and 20, it is going to generating the random value. Now let us run this. Now you can see A is taking the values of what? 16. B is taking the values of what? 12. So this is a range lies between 10 and 20. 10 and 20. Okay. Now I am doing addition operation. A is equal to 16, B is equal to 12. What is C is equal to? 20. Okay. So to print in the particular range, random value in the particular range, you can use what? $U random underscore range. Then you specify the range to generate. So what it will happen if I'm going to give 20, 10? Like 20, 10. If I'm giving 20, 10, is it same? Now 20 is the maximum value, right? 10 is the minimum value. It is going to generating the range between the range of 20 and the 10. Did you understand? So let me clarify the later why $U random, because $U random is a unsigned number, unsigned numbers representation. But earlier case in this program, if I'm using U random also, it is printing the minus number. I'll clarify that later. Let me check the syntax later. Okay. Now, did you understand this program? If suppose if I'm using like this again I'm going to copy the same. Again, I'm assigning the A value and B value. Random value I'm assigning. Then I'm giving the simulation time. Now this will be executing at what simulation time? So I'm just copying and printing the same. If I run this, what output I'm going to give? What is the output I'm going to give? This will start executing at what? 5. This will start executing at what? 10. Okay. So this second $symbol display will be executing at 10. So now let me run this. At t s is equal to 5. So this is a random value it is taking. 16 and 12. And result will be what? 28. And then this will be executed at what time? 10. So this will be executed 0 plus 5. Starting at 0 simulation time. But this is executing at what time? 5 times simulation time. Again, this will be executed at 5 plus 5 is nothing but 10. Now at the 10, what is the A value is? 10. What is the B value is? 12. What is the C value is? 22. So if I'm making my sim time at 15, this $symbol display will execute at what time? 20. Now this will be executing at 20. Third, S is equal to 20. This second $symbol display will be executed. So what is the use of this time data type is used to invoking the current simulation. Invoking the current simulation. This you can also do like this also. So I'm not declaring this with the sim data type, means time data type. Now here I'm going to write like this. Let us write dollar symbol time here. Dollar symbol time. Now I'm not going to pause this case now. So let us do the same here also. I don't need here s is equal to dollar symbol time. Okay. So let us copy this. I will be keeping here also. Now you tell me what is this program execution. Earlier, the dollar symbol time invoked time is assigning to the time variable. Then I am using that variable to print the value. Now in this program, what I did, I am directly using the dollar symbol time. So what is the use of this dollar symbol time here? It is going to invoking the current simulation time. So now this is invoking the current simulation time is 1, 5. So this is going to invoke the current simulation of 1. 5 plus 50 means 20. So inside this initial block, we start executing sequentially. Okay. So what I mean to say, this initial block, these are the statements I have, correct? These are the statements. These statements are start executing what? Sequentially. So we have sequential blocks and the parallel blocks execution. We'll discuss that later. If I want to make this parallel block execution means concurrent execution, then I should go with the concept called as a fork and join concept. Using fork and join, you can make all these are concurrently executed. Okay, here in the initial begin blocks, all these statements will be executed sequentially. We'll see parallel block execution and sequential block execution later. Now you understand this, how this will be start executing. This initial block will be start executing at time t is equal to 0. Okay. At time t is equal to 0, this will be start executing. At the time 5, this will be executed. And time 5 plus 15 means 20. At 20 time, this will be executed. Okay, let us do same. Copy the same. I'm using how many initial blocks now here? 2 initial blocks. So let us run this program. So this first initial block will gives me that this is also start executing at time t is equal to 0. This also time t is equal to 0. So in this initial block at time 5, this is a result. So this will takes. This is a result. And second initial block at time t is equal to 5, this is a result. At 20, this will be executed. Again in this initial block, this will be executed. Later we'll explain you that what is intra and regular delay, then what is zero delay, what is the role of that. So we'll see that later. So as of now, you understand that initial block will be start executing what? Sequentially. Okay. Is it clear this? What is the use of the time data type? What is the use of the time data type in Verilog? To get the simulation time, current simulation time. So we'll be using one system task function is dollar symbol time. Correct. So if I want to assign that value to the variable, then you can declare that variable as a time data. Is it clear? The time data type. This is what the time data type. The keyword will use the time. So the width of this time data type will be by default 64 bits. The dollar symbol time is invoking to get the current simulation time. Now can you see what is this example is? What is this example is? Time. So save underscore sim underscore time is nothing but what here? Is a variable. Time is a keyword for declaring the time data type. So this save underscore sim underscore time is nothing but what? Variable. What variable it is? Time variable. So define a time variable, save underscore sim underscore time. Then we are writing the initial block. So initial block, save underscore sim underscore time is equal to what? Dollar symbol time. So what it is going to do? Dollar symbol time. This dollar symbol time will going to invoking the current simulation time. So that will be assigned into the what? Save underscore means save underscore sim underscore time variable. Did you understand this? If your initial block will be having only one statement, there is no grouping with begin and end. So let me clarify one more thing. Now let us take same example, what we are doing here. Okay. So we have declared with the time data type, right? Time. What is that variable is? Save underscore sim underscore time. I have declared this with the time. Okay. Now I'm going to use the initial block. Initial. If my initial block will be having only one statement, it is not necessary to group with the begin and end. Did you understand? Now I'm going to use this variable save underscore sim underscore time is equal to let me invoke the what? Current simulation. Dollar symbol time. Did you understand? Now I'm going to take one more initial block. Initial block. Here I'm going to display this value. To display the value, what I want to do, to print the value, what I want to do, display, then what I want to print it. Save, correct? Underscore, sim underscore, time is equal to what? Percentage D, or, okay, let me print in the decimal 0D. What argument I need to pass to this? Save, correct? Save underscore, sim underscore, then ins. So this also start executing at what time? T is equal to. So I'm using one more initial block. This also start executing at once. At the 0 time. This is a concurrent execution. Correct. So what is the output I'm going to get for this? What is the output of this program is? So it is going to invoke the what? Current simulation time. What is the current simulation time to this assembly? This is executing at what? Time 0. It is going to invoke the save underscore time is equal to executing at what? 0 simulation time. Did you understand? What is the use of this simulation time? In previous example also I did the same thing. I declared time with what? Variable S. That S is assigning to what? Dollar symbol time. Then I have indicating with the sim time, hash file. Then I'm printing the sim time, simulation time and the result time printing in the previous example. Did you understand? Okay, let us do one thing. This is dollar symbol underscore time. Let me copy this. This is, okay, I have not copied the program for integer data type. I think you can work easily, right? So time data type. Let us copy this program. So one more program. Yeah, this is the one. Let us copy this program. Did you understand? What is the role of this time data type? Any questions are there? You can please go ahead. Any questions, any doubts arises? You can go ahead. See, the simulation time is measured in terms of, will be measured in terms of the seconds. Okay. The unit is denoted by the time data type is nothing but is. Okay. So your model sim will executing at a nanosecond. Some simulators will work at picoseconds simulation. Okay, the time simulation time denoted by the letter is S. Means it is measured in what? In seconds. Did you understand this? So this is regarding about time data. Now let us go with what are the data type we talked about? Integer, before that wide data type, reg data type, integer data type. Okay. Real and time data type. Then I can give one assignment, you can work on that. So you can try to understand the data type of real-time data. Real-time. You know what is the real? What is the use of the real data type is? Floating point. Floating point operation, we can go with the real data type. What is a time data type? To get the current simulation time, execution time, you can go with the time data type. You understand that what is mean by real time data type? You can easily understand what is if you search in any internet, the real time data type. If you have an idea about the real data type and the time data type, you can easily understand the real time data. So that I can give you as assignment. You can try to work on the real time data type. Okay. So now we talked about all the data types which is supported in the Verilog, starting from wide net data type to the time data type. Now let us start with what is arrays. So before going to detail about any programming language, I'm bringing the idea about all these concepts, basics concept. What are the data types it is supported? What is meant by format specifier? How to print a text? How to print the decimal number, floating number? Okay, then only I can be able to write a program so that you can easily understand whatever the program I'm going to write. Okay, so arrays in detail we'll study later. For now, in anywhere, any program, if you see that how you can declare the array, that basic concepts you should know. So that I'm briefly going with the arrays. Arrays and memories we'll talk later in detail. Now let me explain you just a brief about what is the array, how you can declare the array. Okay. So is it array is same as a vector? What is a vector and what is the array? What is a vector and what is the array? Vector is used to define the depth of the variable, whether it is a 2-bit, or a 3-bit, or a 4-bit, or a 5-bit, and so on. Correct. So array, don't get confused array with the vectors. So array is a elements. Okay, let me write one program to this so that you can understand. Now, if I'm going to write like this, let us make reg 7 down to 0 of A. 7 down to 0 of A. What is this? Nothing but, this is nothing but a vector, correct? So let us write a program to this module TP. Now I am declaring the data type. What data type is? Reg data type. What is size of this reg data type is? 8-bit, correct? What is the reg data type is? It is capable of store the data, retain the data, right? Retain the data. So what variable I'm used to declaring this reg data type is A. Now reg is a vector or scalar here. Reg data type is vector or scalar? Vector. Vector 7 down to 0. Now let us write initial begin block. Okay. Now I'm going to assign the value. Let us assign the value since it is declared as a 8-bit. We'll assign the 8-bit data to this. Now this will be understanding in my Verilog, underscore will be understanding. So what value I'm assigning to the A is? What is its size in bits and 8-bit, and number is what? 1010 and then 11. Now this is a vector. Now I want to access the value of 7. Now how it is declaring as a vector it is. Now this is what? A of 0. This is nothing but what? A of 1. This is nothing but 2, 3, 4, 5, 6 and 7. Did you understand? Now what is the A of 0 value is? 1. A of 1 value is 1. A of 2 value is 1. A of 3 value is 1. A of 4 value is 0, 1, 0, 1 respectively. Correct. Now let us do slicing of the vector. Now I want to print only this from this reg with the vector. What I want to do? Now I want to slice it. How to slice this? How to slice? So I want to print only from, let us take 2 to 0. 2 to 0. How to do this? Let me print the dollar symbol display. Okay. Now what I want to print? A 2 down to 0. This is equal to dollar symbol B. Then I am going to write in double quotes. So this is double quotes of A. A of 2 down to 0 is equal to percentage B. Okay. The argument I need to pass as what? I want to slice. What I want to slice? A 2 down to 0. What it is going to do? Okay, before here, one thing. Before going to this, I want to print the 7 value. In this vector, I want to print the 7 value. How to print the 7 value? I can go with what? A of 7. What is A of 7 value is nothing but 1. That has n mod. N mod. Now what is A of 7 is? 1. You can say A of 7 is nothing but what? 1. Now what I did in this basically? I have declared range as a vector. Now I'm done the what? Slicing. I want to get only the A of 7. Now I want to slicing the vector 3 down to 0. How to do? A of, so what I need to slicing here? 3 down to 0. Now what argument I need to pass here? 3 down to 0. 3 down to 0. Now what it is slicing is now? It is taking 0, 1, 2, 3 from this vector. Now it is printing 0 from 0, 1, 2, 3 value. Now this is nothing but what we call is a vector slicing. This is a vector slicing. How do you understand? If I am going to give like this, what is this is nothing but a scalar. Now if I am trying to do this, is it my program is correct? No, correct? Since it is a what? Scalar. If I am trying to assigning 8 bit to this A will take what? Only 1 bit. What bit it is going to take? LSB bit. It is taking LSB bit. Did you understand? So if I run, what type of error I am going to get if I am running this? This argument is not correct, right? Because the argument I am passing is not correct. So I will be getting error can't select the part of the scalar. Now my A is a scalar. Did you understand? Now if I pass like this, is it still I am getting the, now I am getting the output for this program, or I am getting any error? No error? Is it error or no error? No error. Say I am using 8 bit size and number I am using. 8 bits, size is 8. This value is assigning to A, but A is a what? Scalar. Now A will take only this LSB bit, 1. Now I am printing this value. Now it is printing like A 3 colon to 0. Since whatever I am putting here, this is a format specifier. This is printing 3 colon to 0, but this B value takes 1. Now it is printing like A 3 colon 0 is equal to 1. Then vector and scalar and vector, how to do vector slicing? Are you understand? Now let us go with array. Let us go with the array. So how to declare the array is, this is a range I am declaring. Range A of, let us write 7 down to 0. What is this meaning of this is nothing? Earlier I am putting here 7 down to 0, so that you are saying that that is a vector. Now what is the array is nothing but? What is the array? Array is nothing but collection of elements. Now this is a array it is going to create. What array it is going to create is nothing but A of 0, A of 1, A of 2, A of 3, so on. So if I write this array, what is the array I am writing here is nothing but. So this is range I am using, right? Range A of 1. 7 colon 0. 7 colon 0. Now it is creating the array. The array of A of 0, like A of 1, then A of 2, so on, A of 1, A of 7. So each array with the size of how much? Each array with the size of range A I am using. Means it is a 1 bit. Each array will take how many bits? Only 1. Did you understand how our array is created? Now if I am going to write like this, range 7 down to 0 of A, again 7 down to 0. What it is going to, how it is going to create? Now this is the array, correct? Array A of 0 means how many bits it is now? It is 8 bits, 0 down to 0. These are how many bits? 8 bits. These are how many bits? 8 bits. This is also 8 bits. This is also 8 bits. Did you got the difference between vector and the array? This is a vector. If I am going to write like this is what? Vector. Correct. If I am going to write A of 7 down to 0, now this is nothing but what? Array. Array of each array with the, what is the size is? Size of the array is nothing but 8 bit. If I am not going to write anything, any vector specification here, now each, how many array elements are there? 8 array elements. Each will be having a size is what? 1 bit. Did you got the difference between array and the vector? So here arrays are allowed in Verilog for range data type. You can use the arrays for what? Range data type, integer data type, time data type, and vector register data. What I am talking just now, 7 down to 0. Yeah, 7 down to 0 is nothing but what? Vector register data types. Did you understand? Arrays are not allowed for the real variables. Real data type. What is real data type is? Floating numbers. Okay, arrays is allowed for range data type, integer data type, time data type, and vector register data type. Arrays are not allowed for the real data type. Now let us see the syntax about array. How you can declare the array. Array are accessed by array name followed by subscript. This is how you can access the what? Array. How you can access the array is nothing but array name followed by subscript. So A of 0, A of 1, A of 2. Okay, A is nothing but array name. In subscript you are writing what? A of 0 means you are accessing the what? 0 element. A of 1 means first element you are accessing. A of 2 means second element. Okay, so you can see some examples of the array here. Okay, in array, multi-dimensional array is not permitted in the Verilog. You can see integer count to 0 to 7. So this example of what? Integer array. What is array name is? What is array name is? Count. Array of how many count variables these are? 8 count variables. So array of what? 8 count variables this is. Now look at this next example. Range bool of 31 down to 0. What is this is? It is an array of, this is a single bit, right? So this is the array of 32 bit, 32 array. 31 down to 0 means 32. It is 32 of how many bits it is? 1 bit boolean register variable this is. Did you understand? Now look at this time. Time, the array name is what? Check underscore point 1 colon 100. Means what array it is going to create? It is an array of 100 times check point variables. Now you can tell me what is this fourth example is? Range 4 colon to 0. Port underscore ID is 0 colon to 7. So this is array of how many ports? 8 ports. Each port will be having a size is what? 5 bits. Now this is your vector, correct? This is a vector. This is nothing but what? Array. Are you understanding? Now you can see this is what? Integer. The array name is matrix 4 colon 0 or 4 colon 0. So this is an illegal declaration. Means multi-dimensional array is not permitted in the Verilog. So if you are writing the array like this, 4 colon to 0 and 4 colon to 0, this is nothing but illegal declaration multi-dimensional array. Did you understand? So arrays is not allowed for what variables? Real data type variables. So it is allowed for each integer, time and the vector. Did you understand? Now you can see in this example, this array we have declared. If I am using count of access the array element, count of I is I am accessing the array element of what? Which element I am accessing? Fifth element of the array count variable. So this is how you can access the what? Count. Accessing the count of I. Let us take this example. Now I am going to write an array here. What is array is nothing but it is single bit count, right? Single bit count. 0 down to 7. So what is this is nothing but an array. What is array name is nothing but register type array it is, right? Reg type array count of what is the size of this array? 8, not 8 bits. It is array of 8. Array is nothing but a collection of elements. If I am writing 0 down to 7, it is how many array elements are there? 8 elements are there. Each 8 element of the array whose size is nothing but how much? Only 1. Did you understand? Now let us assign the value to this array. How to assign the value of this? I need to assign the value 1. This is a 1, right? So 1 bit 8 array it is. Correct. How to assign the value to the array? So once I can loop this. Using for loop I can assign the value. Iterating the a of I, then assigning the value. So in general how I can assign is nothing but this is how I can assign. So since it is a 1 bit, a of array 0 is nothing but what? 1. Similarly, a of 1 is nothing but, let us assign this to what? 0. Correct? Again, a of 2 is nothing but 1. Let me make 1. So on. Since it is a, how many bit it is? 1 bit. 1 bit, what is array is nothing but. It is a array of 8 count variables. This will take what? Only 1 bit. You understand? Now let me write. Okay, let us assign to the all the array values. This is 3. This is 3 and this is 4. And this is 5. Again, let me make this is 6. This is 7. But each count variable will how many bit it is? 1 bit. Now I want to print the array of 5. How to print the array of 5? So I am declaring this as a count, right? Then it should be count. Sorry. Now what is array name is nothing but count. Now I should write this is a count. Correct, not A. Or if I am writing this is A, then A of 0, A of 1, A of 2. So now let me do one thing. We'll go according to this. Let me assign this to 1. This is 1. This is 2, 3, 4, 5. Again, this is 6. Let me print one more. This is 7. This is 7. Let us assign some random values to this. Means 1s and 0s like this. 1 bit I'm assigning, not random value. Just ones and zeros I'm assigning to the array. Now I want to print this count of 5. Correct. This is what? Look at this example. Integer count 0 down to 7. This is an array of how many? How many count variables? 8 count variables. If I'm using count of 5, so what I'm going to get? It's the fifth element of the array count variable. How to get this fifth count of the array element is what I want to do here. Dollar display, correct. Count of 5, correct. Then I need to pass the one. Count or count of 5. Fifth element I need to access. So I need to write the count of. What is the count of 5 value is nothing but 0. So now I'll be getting this value is nothing but 0. Count of 5 is 0. Did you understand? Now if I'm making this as vector now. Now what is this is? This is an array of 8 count variables. Each array will take what is the size is? 2 bits. So how to assign the 2 bits to this is nothing but. Shall I go with the 2 tick B like 1 1? Correct. So on. This is the size of what? 2 tick B of, let me make 0 0. Correct. Again, there is also 2 tick B. Let me make 1 0. Again 2 tick B 0 0. Again 2 tick B 1 1. Again this is 2 tick B 1 0. Again 2 tick B 0 0. Again 2 tick B. Let me make 1 1. Array of what is the array count variables? 8 counts. 0 count of 1 count of 1. Each array will be having how many bits? 2 bits. Right? This is a vector now. Correct? This is a vector and this is nothing but what? Array. How many elements you are making it? Array elements is 8 elements. Now I want to let us print a count of 4. How to print the count of 4? Count of 4, correct? Again, count of, the argument I need to pass as count of. What is count of 4? It is going to print. Count of 4 is nothing but 1. Now it is 1. A count of 4 is 1. Are you understanding? Now if I am making this as 7 down to 0. Now what is this is? Array of 8 count variables. Each array will take how many? 8 bits. If I am giving 2 tick B0, if I am assigning each array element as 2 tick B, 1 1 or 1 0. So if I am going to print this, what is the output I am going to give? If array of 4 means what? First LSBP is 1 1 and remaining will be what? Zeros. It is printing all the remaining values as zeros. Did you understand? If I print array of count 2, what is array of count 2 is? This is nothing but count of 2 is nothing but 1 0. So first your LSB bit is 0, next bit is 1 and all remaining bits are zeros. So later we'll see that how to iterate. I want to print all the array count values. I can iterate through the while loop or if. So we'll see when you start with the behavioral statements. Okay. So here I'm assigning the array element. I'm printing. So where I want to iterate this, I want to print a count of 0, count of 1, count of 2, count of 3, 4. Then what I need to do in that case, I should put this into the one loop. Did you understand? So this is the array example. Array example. Now you can see this is checkpoint 100. Means what it is going to do? We are declaring the time checkpoint. What is array size is nothing but array is nothing. 100. 1 to 100 means array of 100 times checkpoints variables. Now I am getting checkpoint 100 means what? It is going to get the 100th checkpoint value. What about this port ID of 3? So this is third. What is the port ID of 3 means? This is the one, port ID. This port ID is array of how many ports? 8 ports. Each port will be having size of what? 5 bits. If I'm accessing port ID of 3, what I'm going to get? I'll be getting the third element of the port ID array. This is how many bits it is? 4 down to 0. It should be a 5-bit one. Did you understand this array? You can take up this example. Okay, write a code and analyze and print all this, accessing all the array. Assign the value to the array, then print the or accessing the array values. So this is regarding about array. So it is important to not confuse array with the net array vector. Correct. How to declare the vector? First you are writing the width, means in the square bracket, followed by the variable. Array means what? After the variable. If you write after the variable, that becomes what? Array. Before the variable, that becomes what? Vector. So vector can be used for the netted data type or reg data type also. Netted data type and the reg data type. So a vector is a single element, and that is a n-bit y. Vector is a single element, right? A single element. What is the width you are defining? That will gives the n-bit value. On the other hand, what is array? Array are the multiple elements that are maybe 1 bit or it may be the n-bit y. Can you tell me example to this one? For the 1 bit or n-bit y. You see the difference between vector and the array. A vector is a single element. It is a single element, right? If you write a reg 7 down to 0, A is nothing but single element. What is array is? Multiple elements. If I am writing reg 7 down to 0, A of 7 down to 0 means how many arrays it is going to be? 8 arrays. It is nothing but multiple elements, or we call collection of items or a collection of elements. Each array element consists of width is what? 8 bit. If I am mentioning that is scalar, 1 bit. Did you understand? So example to this is nothing but if I am going to write let's copy this. So how you can write the vector is, if I am writing the vector, so vector is nothing but this is the one, right? It's a vector. Vector of what? It is a single element. Did you want? How to make an array? I can make, again let me write 7 down 0 down to 7 or 7 down to 0, correct? Now this is a array now. Array of each, how many elements are there? How many? 8 variables are. Each variable size is what? 8 bit. This is nothing but what? How many elements are there? 8 elements. Each element will be having 1 bit. That is the definition to this last one. This is the one. So here, other hand, arrays are what? Multiple elements. There may be 1 bit or n